Okay, so today we're going to cover section 4, and today we're going to learn our first shortcut for proving triangles congruent. And that shortcut is called SSS, or the side-side-side postulate. So when we state this as a reason in our proof, all you have to put is SSS. And what this postulate states is if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So no longer do we have to show all 3 sides and all 3 angle pairs are congruent. As long as we can match all 3 sides, we can say the triangles are congruent. He just asked, is there an angle shortcut? No, there's not. Because if you think about it, if you have a teeny tiny equilateral triangle here, and let's say all of these are 60, you can also have a much larger equilateral triangle, but notice the sides aren't the same. So there is no angle congruency postulate. We're going to learn later on about similar figures, and there is an angle similarity postulate, but no congruencies for the 3 angles, only side, side, side. So here's our first example. They want us to check to see if this congruency statement that they're giving us, is this true? And the way that we're going to see if it's true is we're going to make sure that all 3 sides match according to the statement. So I'm going to take it side by side, or one side at a time. So I'm going to do the first 2 letters. So DF and HJ. So I'm going to go over to my picture. DF is over here. Notice it's got 2 markings, and the HJ has 2 markings. So far so good. Then the last 2 letters of each one is the FG and the JK. Notice they both have 3. So far everything's matching up. And now I'll do the last and the first letter. So side DG has 1, and so does HK. So because I have shown that all 3 pairs of sides are congruent, they have the same congruency mark, I can say yes, the statement is true, and my reasoning is I'm using the side, side, side postulate. Now, they might not just give you congruency marks, they might give you numbers. So I'm going to go through and check to make sure that every side matches. So notice here, AC, first 2 letters, is going to match with CA. Well, here we go with our reflexive. It's this side inside here, and it's the same. Then if I do the last 2 letters, CB and AD, CB is here, it's 7. And AD is here, it's 7, so that one matches also. But then if I match side AB, it's got 3, with side CD, it's 4. These are not congruent because 4 does not equal 3. So I can say that no, they're not congruent. And the reason is AB is not congruent to CD, and you can say 3 does not equal 4. So when the sides do not have the same length, then they're not congruent. So as soon as you find one side that fails, the triangles are not congruent. Yes?
Can you put a line between the congruent symbols?
Sure.
When you use it in proof?
Yes. Well, I think what you're going to do is you're not going to be proving things not congruent. I think in your proof it'll be just proving them congruent. But yeah, you could put a slash there because those are not congruent. Everybody with me on that? Okay, let's try another one. So again, let's make sure that all of the sides in the correct order in the congruency statement match with what's actually in the triangle. So again, QP and RS. QP is over here, has 2. RS has 2, so far so good. Then PT, the last 2, and ST. PT has 3, ST has 3. And then if I go for QT, first and last, and it matches TR. So everything looks good. So again, you can say yes, and your reason again is side, side, side. Start graphing the ordered pairs. So I'm going to graph all of my ordered pairs and create my triangle for JKL in blue. And then I'm going to do the RST in red. So go ahead and graph these 3 ordered pairs, connect the dots, make your triangle. Okay, so back to this one. So I'm going to graph the ordered pair J. So -3, -2. So that's J. K is 0 and -2. And L is -3, -8. Now it's going off the graph, so you can just maybe make it 1 box off. So I'll put it right here. I'm going to connect my dots, my points, and make a triangle. Now I'm going to graph RST. So R is 10, 0. S is 10, -3. And T is 4, 0. Again, connect the points, create your triangle. Now, it wants us to show that they're congruent. So in order to see if they're congruent by side, 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 I need to find the length of each side. Now, for the sides that are vertical and horizontal, I can just count the little boxes. However, for that diagonal on each triangle, I have to do the distance formula, just like you did on the quiz. So let me go ahead and label these. So R, and then this is S and T. So the length of RS is going to be 3, if I count little boxes. RT or TR is 6. If I go over here to the blue one, JK is 3. And this point down here was L. JL is 6. So now I need to find the length of KL. And I'm going to do the distance formula. So I'm going to do -3 minus 0 squared plus -8 minus -2 squared. So -3 squared. This becomes -8 plus 2. So -6 squared. This becomes 9 plus 36. Square root of 45. I need to leave it in simplest radical form. So it becomes 3 square root 5. If I do the same thing for ST, the ordered pairs I'm using are these. So if I do 4 minus 10 squared plus 0 minus -3 squared, I get -6 squared plus 3 squared, 36 plus 9, 45, 9 times 5, 3 square root 5. So again, all 3 sides are congruent. So I would say, yes, these 2 triangles are congruent by side, 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 because I've shown that all 3 sides match up. Does that make sense? All right, last slide. It's just a word problem. And it says here to explain why the bench with the diagonal support is stable while the one without the support can collapse. So basically here, in this figure, you're creating 2 congruent triangles. And when you have 2 congruent triangles, they're going to have fixed side lengths, which would make it more stable. So as soon as you add in this stabilizing diagonal, that bench is more stable. Whereas this one, it could move side to side, or it could cave in a little bit, but the one with the diagonal support is more stable because it does create 2 congruent triangles.